We talk about vector quantity, talk about resultant vector. I want to talk about the categories of vector quantity as well as do the calculations under the categories of vector quantity. Now, you might have heard the word vector quantity before. Yeah, vector and scalar quantity. Now, let me tell you what is scalar quantity. Scalar quantity, these are quantities that only have magnitude but no direction. Whereas a vector quantity, these are quantities that have both magnitude and direction. Now, generally, direction, we all know what direction means. It means path. Yes, means path. Now, most of us we find the word magnitude confusing. Now, magnitude just means number or amount. Magnitude means numbers or amount, numerical value. Let me show you. For example, let's say a car moving with a speed of, okay, let's say this is a car now. Okay, let's say this is a car, and this is another car. Okay, let's say this is another car. Now let's say this car is moving with a velocity of 50 meters per second, and this other car is moving with a velocity of, let's say, 10 meters per second. Now the magnitude here, okay, let's say this one is moving with a velocity of 50 meters per second due east, while this one 10 meters per second due east as well. Now due east, this due east just shows the direction in which the car is moving. But if you look at these other values here, this 50 and this 10, now this first car is moving, let's say car A, let's say moving at a speed of, at a velocity of 50 meters per second. Now this 50 here is known as the magnitude. The 10 here is known as the magnitude. Magnitude just simply means amount or numbers. It's not a big deal. It means amount of number. Let's say, for example, a force of 80 Newton act on a body. A force of 100 Newton act on a body. The 100 there is the magnitude. Magnitude just means amount or number. 10 Newton, 5 Newton, whatever the case may be. So a vector quantity, a quantity that has both magnitude and direction. Now let's dive deeper. A vector is represented by what? An arrow. If you look at the arrow here. Now, if you look at everything, you find out that the head of the arrow represents what? The direction of the vector. Remember, a vector is represented by what? By an arrow, where the head of the arrow represents the direction of the vector, and the tail, the length of the tail represents the magnitude of the vector. Now let me explain. We normally represent vector by an arrow. In physics, we normally represent vector by an arrow. The head of the arrow represents the direction of the vector, while the tail, the length, not just the tail, the length of the tail represents the magnitude of the vector. Let me give you guys an example. Now let's say two vectors, now vector A and let's say vector B. Now let's say vector A, remember I told you guys magnitude just means amount or numbers. And let's say vector A has a magnitude of let's say 10 Newton, and vector B has a magnitude of what? Let's say 30 Newton. Now if you look at these two vectors, though both of them are going the same direction, now it's due east, but there is something that differentiates them. What differentiates them is their magnitude. If you look at vector A, remember I told you guys the length of the tail of the arrow represents the magnitude. Now if you look at these two tails, the tail of B is longer than that of A. So if you look at A, the tail is shorter compared to that of B. Now the magnitude of, remember I told you guys that the length of the tail of a vector represents the magnitude. Look at this one is 10, and look at this other one is 30. You find out that this one is longer than this one. I cannot go and put something. I cannot do something like this. Let's say I will say, okay, I'll put 30 here. Then I'll put 10 here. I'll put 10 here. This is not correct in the sense that we all know that the tail of the vector represents what? The magnitude of the vector. If the vector magnitude is 10, the tail should have been what? Should have been shorter. And if this one is 30, should have been what? Longer. So the length of the tail of the arrow represents the magnitude of the vector. For example, let's say a vector of, let's say, okay, 5 Newton, another vector of what? 2 Newton. 5 is greater than 5 is greater than 2. 5 is greater than 2. So you find out that the tail of vector B is shorter than the tail of what? Vector A. Because of what? Because of their different magnitude. 5 is greater than 2. So the tail of the arrow represents what? The magnitude. So now we move further to what? Resultant vector. A resultant vector is that single vector that have the same effect in magnitude and direction as a group of vectors acting together. Now, you please, if you are to write JAM or pursue TME or WAEC, please, especially the JAM bar, take note of this definition, and as well as if you are writing WAEC, take note of this definition. Normally, JAM does not majorly ask the definition in physics, but if they want to ask the definition, they majorly ask questions from here. Yeah, this definition has been found in one particular year in JAM past question. Now, resonant vector is that single vector that have the same effect in magnitude and direction as a group of vectors acting together. Now, let me explain. If you hear the word resultant, resultant just means total or net. Resultant just means total or what? Net. For example, now, resultant vector just means total or what? Or net. For example, let's say I combine two vectors now. Okay. Let's say I combine two vector. Let's say vector A has a magnitude of 5 and vector B has a magnitude of 3. Let's say I combine two vectors. The total one is known as what? The resultant vector. When you combine two or more vectors together, the total vector that is what? Is the resultant. So resultant vector just simply means the total vector or what? The net vector. Net also means total. So resultant vector is that single vector that have the same effect in magnitude and in direction as a group of vectors acting together. Now we move to categories of vectors. Now there are 4 categories of vector quantity. We have parallel vectors, we have anti-parallel vectors, we have perpendicular vectors, and we have a diagonal vector. Now let's talk about parallel vectors. Properties of parallel vector. 1. They have the highest resultant. Or maximum resultant. Remember, I told you guys that resultant just means total. Resultant vector means total. So please take note of these properties. These are the properties of parallel vectors. 1. They have the highest resultant or the maximum resultant. It's an exam-based question. 2. They have angular difference of 0. All these are exam-based questions. They travel in the same direction. Their resultant, which is their total, is calculated by simple addition. If you look at this example, e.g., see vector A and look at vector B. Now remember, if you look at these four properties of parallel vector, how do you know parallel vectors? Now, we know them in the sense that they go in the same direction. Looking at vector A and vector B, both of them go in the same direction, due east. If they don't go in the same direction, those vectors, they are not parallel vector. For parallel vectors, they go in the same direction. These are two vectors. These two vectors are parallel vectors because they go in the same direction. How do we get their total? How do we get their total? We get their total, which is the resultant, by simple addition. We just adding them. If we add them, we have what the total resultant, which is 8. Now let me expatiate more on this number 1. They have the highest resultant. Do you know why? Do you know why they have the highest maximum resultant? This is because the resultant itself is calculated by what? Addition. For example, you adding 5 and 3 together to give you what? 8, which is very large compared to 5 and 3 themselves. So take note, parallel vectors, they have in all of these categories of vectors, parallel vectors, they have the highest resultant. Whenever you add them, their resultant is always highest, it's always maximum. It's an exam-based question. And also they have angular difference of 0, which is very true, because they are in a straight line. They have angular difference of what? 0. Then they travel in the same direction. That's how we know them. Their resultant is calculated by simple addition. Yeah, this is very easy. Now let me just give you guys 2 questions. Okay, now this is the first question. Look at the 2 vectors, now vector A and vector B. How can you tell they are parallel vectors? This is because we can tell that they are parallel vector because why? Because they go in the same direction. Look at them, they go in the same direction. So this is why they have parallel vectors. And remember, how can we calculate for what? The total. How can we calculate the total of parallel vectors? Remember, the total, we know that total vector is known as the resultant vector or the what? Or the net vector. We calculate the total by just adding them, by simple addition. Adding these 2 give us what? This 13 plus 7 give us 20. So adding the 2 give us what? 20. So the resultant is what? 20. We usually represent resultant with arrow. The resultant vector is what? 20. If you look at it, the magnitude, the tail, is even longer than both of them. I remember parallel vectors, they have the highest resultant or the maximum resultant, and they have angular difference of 0. They travel in the same direction, and their resultant is calculated by simple addition. We add them by just add. We calculate for their total, which is their resultant, by just adding them. Now let's move to anti-parallel vectors.